So in section 10.4, we're going to work with the graphs of parabolas. Now, quite often they come to us in this form, but we'll find it easier to work with in this form in terms of being able to find the vertex. And when you graph a parabola, often they're going to look like this. And there's several points that would be of interest to me in graphing this. So let's take a look at those points. I wish I would have drawn this a little bit better. Yeah. The point down here that, of course, is the main interest for me is the vertex. I want to know what that point is. Quite often, I'll also want to know where the graph crosses the x-axis. So there's going to be your x-intercepts. And this is why I wasn't terribly happy with my graphs, because really close to the vertex is where the graph crosses the y-axis. What would that be called? What's the name of that point? Someone make me look good. What's the
axis of symmetry?
The axis of symmetry is something we have to look at, but the point where it crosses the y-axis is the
Y-intercept.
Y-intercept. Thank you. So that's the Y-intercept. And yeah, let me draw in one other feature of this graph. I appreciate the reminder there. The vertical line that goes through the vertex like this is your axis of symmetry. And it's always going to have an equation of x equals something. It's going to be x equals the x coordinate of your vertex. That's going to be this vertical line. So whatever that is, fill that in. Now, in terms of finding some of these points, the nicest one to find is the vertex if you have your parabola in this form. Then it's just the value of x that makes the squared term equal to 0. In this case, it'd be an h. If that was 0, you'd be left with a k. So your vertex in this case would be h and k. To find your y-intercept happens along this line, and that's when x equals 0. So you set x equal to 0. How about the x-intercepts? What are you going to do to find those?
Set y equal to 0?
Set y equals 0. Good. Because this is the line y equals 0 all along here, and where this graph crosses the y-axis, y has to be 0. So then you solve for x. Now, the big chore is going to be getting the parabola in this form in order to graph it. So let's take a look at an example. That would be f of x equals 2x squared minus 8x plus 6. So I'm going to want to rewrite that in a couple ways. I guess the first thing I'll do is I'll replace the f of x by y, just because it's a more comfortable notation for us. And then I'm going to start completing the square. So my way of doing it is just to move the 6 to the left-hand side. Negative 6 plus y equals 2x squared minus 8x. To complete the square, I can't have a number in front of my x squared term. So I'm going to factor out the 2 from that x squared term, and I also have to factor out the 2 from this term. Now, a lot of people get tripped up at this point because they want to factor out the 2 and the x. They're factoring out the GCF. That's not the case. You're just factoring out this coefficient like that. And if you check it, 2x squared minus 8x, we got the same thing. Now comes the part where we complete the square. So let's see about that. We've got a negative 6 plus y, x squared minus 4x plus something. You remember the process of completing the square from section 10.1. Remember, you take half of some number. Which number am I going to take half of?
Negative 4?
Yeah, half of negative 4 is negative 2.
And then square it.
Yep, and then square it. So that puts a 4 here. But I'm not going to put a 4 on the left-hand side. I got to be a little bit more careful than that. Because really by putting a 4 here, I've not increased the right-hand side by 4, I've increased it by 2 times 4. So what do I have to put over here to keep things in balance?
8.
8. Perfect. This is the hard part. So let me pause here. Are we okay with this step? All right. Let's continue to clean this up a little bit. 8 minus 6 is 2, so I get 2 plus y equals 2 times, well, this is a perfect square trinomial. And that's actually the square of a binomial. What binomial do I square to get this?
-2 and -2.
So x minus 2, in other words. So this is x minus 2 squared, and that's perfect. Thank you. This is what we wanted. And what I'm going to do with that now is I'm going to move this 2 back to the other side. And that'll be the form that I want it in. So let me bring that up here. So if I move the 2 to the other side, I get y equals 2 times x minus 2 squared minus 2 again. And that's what I wanted. I needed it in that form so that I can figure out what the vertex is. In fact, what I'm hoping is that you can just kind of look at these things and determine some of that information. So I'm going to keep track of the little t-table here of some of the important points that I'm interested in. And the first one is going to be the vertex. Start with the value of x that makes the squared term equal to 0. So just ignore everything else. What would I put in there to make that a 0? What value of x?
2.
2.
2. And then when I square it, 2 minus 2 is 0. 0 squared is still 0. Times 2 is still 0. Wow. If I put in x equal 2, what do I get for y? What's left when I put in a 2?
-2.
-2. Good. So -2. So that's the first important point that I want. The next important point that I want is going to be the y-intercept. So for the y-intercept, the thing was to set x equal to 0. So let me do that. Now, before I do that, I'm going to give you a choice because we've got 2 different formats of my equation. There's this one here, and there's this one here. These are both equivalent forms of the same equation. So where would it be easier to put in a 0? For the pink formula or for the green version of this?
Pink
Where do you
one.
think it'd be easier to put in? I like the pink one because if you put in a 0, oh, that's 0, and that's a 0. In fact, f of 0 would then be what? Can you just read it off?
6.
6, yeah. So if I put in a 0, I get a 6. Now, what if I did that over here? Well, 0 minus 2 is -2, squared is 4, times 2 is 8, minus 2 is 6. So I get the same thing, which is good, but, you know, it's more work. I like it here better. So this is great for determining the vertex. This is better for determining the x and y intercepts. So as far as determining the y-intercept is concerned, excuse me, the x-intercept is concerned, we're going to set y equal to 0. So let's do that. Figure out the x-intercepts. I get 0 equals 2x squared minus 8x plus 6. And you've got a couple of ways you could solve this. What comes to your mind? How would you solve this one?
Factor it.
Factor it, absolutely. Now, if you're not good at factoring, what's your backup? What's like, okay, I guess I'll have to do it this way. What's your backup if you can't factor that?
The quadratic formula.
Awesome, awesome, the quadratic formula. But try factoring first, and in particular, the golden rule for factoring is always try and factor out a GCF. And guess what? Factoring out a GCF makes a delightful difference here, because we get 2 times all this, and pretty much you can ignore the 2. 2's not going to make any difference in all this, because it factors as 2 times x and an x, 2 things that multiply to positive 3 and add to negative 4. Any takers?
-3 and -1.
Thank you. Negative 3 and negative 1. So I've got this times this times this equals 0. Well, when could this term be 0? What value of x? Don't make one person do all the work. Someone else help me out.
4.
That's a 1 there. So if x equals 1, 1 minus 1, that would be 0, and this whole thing would be 0. Or where else? What else could happen that would make this product 0? What's the other value for x here?
3.
3. So 3 or 1. Now 2 can't equal 0, so that's why I can ignore that there. Now, if you're not happy with this, you can always use a quadratic formula. But let's take note of what we did. We set y equal to 0, and we got 2 values of x. We got x is 1 or x is 3. And that's perfect. Now, in a face-to-face class, I'd be asking you to graph this using all 4 points. On Webassign, you're not necessarily going to need to know all 4 points to graph these things. You're going to need to graph them using 2 points. So before I talk about graphing this on Webassign, are you okay with the 4 points that we found and the mechanics that we did to find those things?
Yes.
All right. Now on Webassign, a lot of times they're going to give you a graph, and you're going to be asked to graph a parabola. Let me see if I can't find one. Here we go. Well, the graphs are going to go from 10 to 10. A lot of times I like you graphing, or I think it's easiest to graph the vertex and the y-intercept. But I had somebody in my last class that had a problem that had a y-intercept that was greater than 11, which is the maximum on this graph. So then what do you do? Well, that's a good question. And let me share with you the answer. Let's say we had something to graph like y equals 2 times x plus 3 squared minus 1. Okay, so let's practice finding the vertex real quick. Where's the vertex?
-3.
-3, -1.
-1.
-3, -1. Perfect. But if you're trying to find the y-intercept, that means you're going to set x equal to 0. 0 plus 3 is 3, squared is 9, times 2 is 18, minus 1 is 17. And wait a minute, that's too tall for your graph. And Webassign is not going to let you rescale the graph anyways. So what you have to do is you have to figure out a different point to graph. My suggestion is you pick something really close to the x coordinate of your vertex. And there's two candidates, -2 and how about -2 here and -4 here. So just pick one of those. Pick something that's close to it. That way you're going to get something that'll fit on your graph. So if I chose, for instance, I don't know, you pick one for me, -4 or -2. No takers? -4. If I put in -4, -4 plus 3 is -1. -1 squared is +1. So 2 times 1 minus 1 gives me 1. Okay. Yeah. So that's a point that'll fit on your graph. And when it comes to graphing, what you're going to need to do is graph a couple points. So you plot these 2 points here, and then you click the parabola tool, and it should fit a graph to your 2 points. You just need to find 2 of them. So
Hi, Professor Parent, just to make sure I'm understanding the process you just went through, you were saying that in Webassign, it won't let us rescale the graph. And so to
Correct.
find the x-intercepts, we need to try different values to allow it to graph so that we can then let Webassign show us what the x-intercepts are.
now you're not necessarily finding the x-intercepts, you're just finding another point. Finding the x-intercepts would mean setting y equal to 0. But in this case, you're just finding another point that's on the graph. Unfortunately, some of the points you choose won't fit on the graph. So you have to choose something that fits on the graph. And my suggestion is you just find a point that's close to the vertex, and that's going to fit on the graph. So that's what I was saying. Finding the x-intercept for this one would be a little bit of a challenge because you'd have to set y equal to 0 and then solve for x. And it's going to be a messy point. You would actually end up using the square root property. I'd move the 1 to the other side and then divide both sides by 2. And then I take the square root on both sides. On the right-hand side, I end up taking plus or minus a square root. And then to solve for x, I'd move this to the other side where it becomes -3. And you'd have 2 solutions there. All right, but I don't think they're going to give you anything like that. Our goal is just to simply find another point that'll fit on the graph. And that's why we looked for points near the vertex. Does that help out?
Yes, thank you.
Okay, appreciate the question, Z. Anything else on that one? All right, let me give you one more example of a problem. In fact, actually, you know what? Let me take a look at this one real quick here. If we can, we'll take a look at its graph. And let's see, got to go to Desmos. There, something like that. So when we're solving for the x-intercepts, we're solving for where the graph crosses the x-axis. Now, the number of solutions you get is going to depend on the particulars of your graph. So in this case, you can see that I've got 2 solutions here, one here and one here. The graph crosses the x-axis at 2 places. But that's not always going to be the case. Sometimes the graph will touch the x-axis exactly at 1 place. Now the fancy word for this is that the graph is said to osculate the x-axis. It's a fancy Latin word, means to kiss it. It's only touching the graph once, which is okay, but that means there's only going to be one solution. And that one solution is also the vertex of your graph. So this point is doing kind of like triple duty. It's the vertex and the x-intercepts. What if the graph looked like, say, this? How many times does a graph cross the x-axis?
None.
None. So what's happening is that it crosses the x-axis only in your imagination, which is when you get imaginary solutions to your quadratic equations, is because the graph has no real x-intercepts. It has imaginary ones. So a little geometric interpretation for why you get imaginary roots sometimes when you're solving complex or solving quadratic equations. All right, so let me do one last problem here for us. And it kind of relates to the things that we just saw. And that is f of x equals 4x squared plus 12x plus 9. Now I'm going to remind you of something with regard to factoring after I point out something about the n terms here. These are perfect squares. What would I square to get 9?
3.
3.
3. What do I square to get 4x squared?
2x.
2x.
Thank you both. So 2x. Now, when you're factoring things, one of the special forms that you can run into is this: a squared plus 2ab plus b squared. And if you factor this out, it turns out that this is really a plus b squared. So if you happen to see that the n terms are perfect squares like this, then what you want to check is, does the middle term turn out to be 2 times a times b? Is it fit that pattern? Well, if this is my a and this is my b, and if I check 2 times a times b, that's going to be 2 times 2x times 3. 2 times 2 is 4 times 3 is 12x. And guess what? I've got a match. So this is a kind of a fancy long-winded way of saying, oh, that's really going to factor into 2x plus 3 squared. And that's it, you're done. You don't have to do all that work of completing the square or something like that. This is a nice perfect square trinomial, and now you can do all your other work. In fact, all your other work is really going to amount to finding 2 points. You're going to find the y-intercept and the vertex. Let's start with the vertex. Actually, you know what? I changed my mind. We're going to start with the y-intercept. What do I have to do to find the y-intercept? Does anyone remember?
X equal to 0.
Set x equal to 0. Perfect. So if I set x equal to 0, now I get 4 times 0 squared plus 12 times 0 plus 9 equals, oh yeah, equals 9. So cool. Thank you. 0 and 9. For the vertex, I need to figure out what makes the squared term equal to 0. So in other words, when does 2x plus 3 equal 0? And it'd be negative 3 over 2. So negative 3 over 2 is my solution there. And if I have x equal negative 3 over 2, that makes this whole thing 0. And when I square it, it's still 0. And then that's it. So I've got these 2 points on my graph. This one is your vertex, and it's your x-intercept. We can see that if we look at the graph. Let me switch over to the graph here. Let's shut this other one off. So you can see exactly the points we were talking about. There's -1.5 or -3/2 and 0 and 9. Those are the only 2 easy points you're going to get off this graph. Let me show you kind of a follow-up to that one. And it ties in with stuff that we did earlier in the semester. What if I asked you to graph f of x equals x squared minus 10x plus 25? So this is, again, kind of a little heads up for stuff that you're going to see in your homework. What I'd like for you to see is, oh, wait a minute, that's a perfect square. And oh yeah, that is too. So what you might want to check is, does the middle term satisfy, being of the form 2 times a times b? Because this one's a squared minus 2ab plus b squared is another perfect square. You square x and a 5 here, x minus 5 squared is how this one's going to factor. This is already a perfect square. And there's really only going to be 2 points that you're going to be able to see very easily from this. X and y. The vertex is going to be 5 and 0. Can anyone tell me what the y-intercept is going to be?
25.
Excellent. If you put in a 0, that's 0, that's 0, you're left with 25. 25 is probably not going to fit on our graph. So somebody remember what we did or what I suggested when you have, a graph like this that doesn't fit too well? You're going to need one more point.
Choose something like 6 or 4 that's close to the x-intercept or the vertex.
Perfect. Thank you, Michael. So we're going to choose something that's close to the x-coordinate of the vertex. So x equals 6 or x equals 4. Let's choose x equals 6 because then you get a positive, right? 6 minus 5 is 1. 1 squared is 1. So 6 and 1. So those would be a couple points that you could plot in order to get the graph of this on Webassign. So, cool. So
I apologize. I have a question for you.
Oh, no need to apologize. I appreciate it. Thank you.
Yep. So just to make sure that I'm understanding, this 5, where the value x is equal to 5 and y is 0, that is our vertex point, right?
Yes. So,
okay.
Yeah. Let me show you the graph over here. I'm going to cheat. I'm just going to do x minus 5. And in fact, if you think back to what we did a long time ago, we did some shifting of graphs, right? So one of the graphs we worked with was x equal or y equals x squared. And this graph is just shifted 5 units to the right, right? You can see the vertex here at 5, 0. And if I change the scale, we should be able to see the y-intercept as well, right here at 25. Is that what you needed, Z?
It is. Thank you.
Awesome. Anything else on this one? Okay, so I'm going to stop things here, put you in your breakout rooms, and get you going on